Charge gun. If we've got something that can fire charges, all we're saying is that we should be able to convert electric potential energy into kinetic energy. Yeah? Now we said yesterday, was it yesterday? No, it was Friday. Oh my gosh, it was last week. I can't believe it. We said last week that when you move a charge from one side of a plate to the other side of a plate, you have to charge gun. Anyway, when you move a charge from one side of a plate to another side of a plate, you have to do work upon it. And if you're moving it from one side of a plate to another side of the plate, you're changing the electric potential of that charge as it moves across. And it's going across a distance r. Okay, and we said that electric potential energy, or change in electric potential energy, is equal to the amount of charge that's being moved times the electric potential through which it's being moved. So when we say electric potential energy is equal to change in kinetic energy, we're really saying that it's equal to negative Q delta V and 1/2 mv2 squared minus 1/2 mv1 squared. Change in kinetic energy equal to change in electric potential energy. So you can imagine this positive on the left-hand side here near the positive plate, is it going to get forced to the right or forced to the left? Well, it's positive and a positive, so it's going to get forced. Whoopsie.
It's going to be a negative attraction.
Yeah.
Double.
Sure. Well, I mean, when it gets there, what happens? I mean, I guess it stops, right? So here's what I'd like to propose. If it would stop by smacking into a wall ordinarily, what I'd like to propose is we kind of remove the obstruction. So I'm going to put a charged plate on one side, and on the other side, instead of it being a complete plate, I want to propose that we could cut a hole in it.
Wouldn't it just stick to the sides?
Well, if it starts off at this point, if somehow we're able to emit protons or positive charges or whatever,
why would it go
from right
straight,
here.
or why wouldn't it go and hit the negative side?
Well, remember the electric fields are oriented uniformly, right? So it's going to, remember we said at one point that positive charges kind of get washed along with the orientation of the electric field lines. So it's going to go straight across. And as it goes straight across, if it starts with zero kinetic energy, by the time it gets over to this side, it will have picked up kinetic energy. Yes, sir?
So then, will it, depending on the speed, possibly, the speed and the mass, possibly be stopped and stay in that gap? And then otherwise,
Oh, no, it should, the momentum should carry it through the gap and keep on going out this direction with some velocity that we could calculate, v2.
what if it's like really light?
Well, if it's really light, then I guess it won't be a candidate for this. Okay? Likewise, if it doesn't have a positive charge, it wouldn't be a candidate for this either. All right. So here's the scenario. We got a positive charge next to a positive plate somehow. It gets repelled from the positive plate and attracted by the negative plate simultaneously. Electric field orientations indicate that it's going to get fired horizontally, and if we provide an escape route for it, that would be like a hole that's cut in this plate on the right-hand side, then it's going to coast on out the other side. Okay? What if after it coasts out the other side, it encounters this? A horizontal plate, also with a voltage across it. What would happen is this positive charge, remember it's positive, enters this plate. You guys told me this once before. Paige is doing sign language. Which way does it go, Paige? Up, yeah, parabolic, right? So it's going to do this parabolic path upwards till it gets to here. Turns out, if I could control the voltage between these two plates, could I control how much up it goes? Yeah, I could control the sharpness of this parabolic curve, if you like. In effect, I could steer it. I could steer it more up and more down. How could I steer it down? Yeah, flip the polarity. I could actually flip the polarity on these plates, make the top positive, the down and the bottom negative. I could steer this thing up or down. That's actually some pretty good control. Yeah,
This is like the chopper game. We have to steer the chopper through the cave.
just like the chopper game. Yeah, just like a video game.
Yes.
Now, here's the part where it gets hard to picture on a drawing like this. I can steer it up and down. I can accelerate it forward. Now, this is two plates that are vertically oriented, one in front of the other. Now, if one is the positive and one is the negative, what could I do now if it goes between these two plates? Yeah, I could steer it left and right. So if I steered it up, now this one's positive, this one's negative. Is it going to get steered right or left if it's a positive charge? Sorry, is it going to get steered away from us or towards us?
It's gonna go away.
Away from us. Okay, so this thing goes through, and assume that I've drawn it just right. It's going to somehow curve off in this direction, away from us. Now, if I were able to put a screen here, like a target, we've at this point sped it up, we've steered it upwards, we've steered it away from us. If I put a screen, like a target, in its path, where would it be on the screen? Yep,
It'd be like in the far corner.
far top corner, right?
Yeah.
Okay. Turns out that the inside workings of a television aren't too far off this. There's some other things that might be used to steer, but these are some of the basics that might be used to steer charged particles. Now, if you get a charged particle hitting a phosphorescent screen, you guys know what happens when an energetic particle hits a phosphorescent screen? Yeah, it glows. It emits a photon. It excites the stuff that's there, the phosphorescent material. It emits a photon. Usually we get these cheapo ones, the old-fashioned kind, emitting green photons. And you can excite different parts of it. And if I was able to fire a lot of electrons and I had the steering control mechanism somehow in place so that I could rapid fire these electrons, boom, 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 maybe I could do thousands per second.
That's pretty cool.
Could I build up an image?
Yeah.
Nice glowing little image. Okay? That's not a bad technology. And it's based on some physics that you guys currently have your handle on, okay?